Sometimes the world around us can seem chaotic. Luckily, physicists have found ways to organize it. In fact, they have developed a system that organizes just about everything around us.
The Standard Model, sometimes referred to as the theory of almost everything, is a mathematical theory that classifies all of the known elementary particles and carrier particles of fundamental forces.
In this video, I will explain the Standard Model of particles in terms of something with which most of us are painfully familiar: a school dance.
Welcome to the particle dance, where you will see the social interaction of various quarks, leptons, and their antimatter counterparts with the help of carrier particles. First, let me introduce you to the elementary particles that form all of the matter around you, leptons and quarks. All antimatter is composed of antileptons and antiquarks.
Now let's go a bit deeper, starting with quarks.
There are 6 flavors organized into 3 generations: up and down, charm and strange, and top and bottom. Quarks have fractional electrical charges, and they also have color charge. Quarks can have red, blue, or green color charge. Antiquarks can be anti-red, anti-blue, or anti-green. Quarks combine into particles called hadrons based on 2 rules relating to electrical and color charge. There are 2 types of hadrons. Baryons are hadrons made of 3 quarks. Examples include protons and neutrons. In the proton displayed here, you can see that their colors and charges cancel. Mesons are the slow dancers, or particles made of just 1 quark and 1 antiquark.
Now meet the other elementary particles of mass, leptons.
Like quarks, there are 6 flavors of leptons. Electrons, muons, and tau have electrical charge, and the 3 types of neutrino don't. There is 1 neutrino associated by generation with each of the charged leptons. Muon and tau leptons are so unstable and rowdy at the party that they decay or are kicked out in place of smaller, calmer particles. Electrons and neutrinos are much more stable. These dance groupings are what makes everything around us. Now that you've met the building blocks of mass, let's look at the rest of the Standard Model.
As we review the carrier particles, I will cover the fundamental forces they are associated with.
Electromagnetism causes things to repel and attract. The carrier particles are photons. The strong force holds quarks in the nucleus together. The carrier particles are called gluons. Finally, there is weak force, which is responsible for subatomic decay. The carrier particles are W and Z bosons. Now for the final piece of our puzzle, the Higgs boson. This particle was found in 2012 and is thought to be responsible for mass.
One goal of physics is to simplify the world into its most basic parts, and the Standard Model does just that. Physicists are hoping to use the Large Hadron Collider to learn more about the way particles interact on their quest to complete the theory of everything.